Everyone, I'm Alice Angley from AusIMM in Melbourne, Australia. I'd like to thank everyone for attending the live webinar today and those who are viewing this recorded webinar. This webinar has been organised by the AusIMM Metallurgical Society. So we'll now start the webinar. Over to you, Peter.
Okay, thanks, Alice. Just changing the presenter view on there. All right, excellent. So I just want to start by just a bit of an idea before we start with any formal introductions, is to think about the power of data. Not sure how many of you are actually addicted to Netflix and watching all the documentaries and things that's on there. There's currently a documentary that's been running about Cambridge Analytica. And what's very interesting is how the Facebook data has actually been used to swing the US election and also the whole vote on Brexit. So it's just something interesting to think about where in the last few years where data is going and how the use of data is actually transforming the world, not only in one area but across many areas, and it can have some really profound effects. So with that, I'm going to introduce the topic of today, which is really on IIoT, and we decided to, I've registered to or volunteered to do this webinar quite a while ago, and recently Brian Whitehead has actually joined us as well. So I'm the business director of Process IQ, and I'm also the chairman of a company called Alway IQ, which is a joint venture company between Process IQ and Alway Mineral Consultants. Brian has recently joined Process IQ. He was the technical manager for Northern Platinum in South Africa. He's with me here in Perth today, but he will actually be based in Stellenbosch, South Africa, to man our office down there and actually service the African market. So welcome, Brian. Thanks for joining me today with this conversation. So I just wanted to add something more about Brian, which I found really inspiring and interesting. Brian was in a very, very good position at Northern Platinum, and he actually decided to put a halt in his career, and instead of moving on to metallurgy manager, he decided to move down to Stellenbosch and finish his technology management degree with a focus on IoT. And actually now which means he's also available to work for us. But it's a really inspiring move for me to think that somebody will actually give up quite a lucrative career in the mining industry to really completely change direction and focus on technology and on the technology space. So how did you come to that sort of decision, Brian? Now, why did you decide IoT is the way to go?
Yeah, well, thanks for that good introduction, Peter. Really appreciate that. So yeah, we, in the position that I had at Northern, it didn't take a lot to realize, where things are going and, where the world's basically moving towards. And yeah, we basically into a revolution in terms of a digital revolution. And, we could either, I basically, decided on which side of the line I want to be. You can either be on the disrupted side, or you can be the disruptor. So yeah, so if you, and so basically me making the move was just, marrying my two passions, mineral processing and the IoT part.
Okay, so just a bit of background about Process IQ. We actually borrowed this, or came across this concept from the Mets Ignited, and when they promoted this idea, it sort of made us realize as Process IQ where we fit into the world. And what the concept was that they conveyed was that in the mining industry, there's now so many suppliers, small METS companies, large METS companies, research and development organizations, and everybody seems to have a silver bullet for the mining industry to fix all their problems. And everybody thinks that they've got the ultimate solution. On the other side, side of the coin, the poor miners are sitting there. They're getting less and less people on site. They're more overloaded. They really have very limited time to evaluate all these different options and quite often small parts of a bigger solution. So the concept was introduced of having integrator METS companies. And I think the first time I started to say, hey, that's exactly what we're doing. So that was really inspiring to me to think that, yes, we do actually have quite an important place in the world. And we started with this concept quite a few years ago already. And on the basis of that, we actually developed this value invention platform, which is an IoT platform, which actually helps us to integrate different parts of a solution and be able to provide a full end-to-end solution for mining companies. So we've done the introduction now. So we're going to talk a little bit more just about digitalization and giving a bit of technical background. We're going to try and focus. So we'll talk a bit about the evolution of technology, but at the end of the day, we really want to focus on the business cases and the application of IoT technology. Give some examples, and at the end, we want to give one recent example of how IoT has enabled us to put a whole lot of different disciplines together to help improve a particular mine's throughput by over 18%. So it's worthwhile sticking around to the end. We left the best bits right till the end. So in terms of terminology, Brian, maybe I'm going to throw this one over to you again. We've got the words digitalization, and digital transformation. It seems to be floating around everywhere. Just to be clear, what is actually meant by this?
Yeah, so I think, there's a lot of name dropping nowadays with, big words like IoT and digitalization and Industry 4.0 and things like that. So if you look at digitalization in the most basic sense, it's literally converting, information to ones and zeros, and that enables computers to process, transmit, and, to do a lot of computations on that data. And then the digitalization is basically then applying this digitization throughout the business process. So basically leveraging the digital data and technologies. And then if you take it one step up again, digital transformation would then be to actually implement the digitalization, enterprise-wide, so throughout your entire enterprise.
Okay, so why is this actually important? And I think, my very first job, I still remember I started working, and my first job was doing failure investigations. And my mentor at that time told me that assumptions is the mother of all F-ups. I think you've all heard that one before. But, we've got a better way of saying it is without data, he's just another guy with an opinion. I think somebody actually said that, so I'm not sure who we should have quoted there. But that's really what it's all about. I mean, have you seen any examples of how people can actually make the wrong sort of assumption on mines or using incorrect data?
Yeah, well, I think it happens all the time. I think if there are any metallurgists in the audience, they'll all know that we all have that one sheet or that one value that we had to assume in the metal accounting. And yeah, so I mean, I think it's scary sometimes to think just how much risk is built into some of the data. Well, our little data we have and how big the decisions are that we make without that data in mining.
So the next slide, we're talking a little bit about digitalization in the mining industry. Again, there's quite a lot of debate about this and differences of opinion. We found this slide actually thanks to ABB. But you can see there that mining is just above agriculture in terms of digitalization, which is interesting to me, although you do find instances where there's quite a high level of adoption of digitalization in specific areas in mining. But mining is, quite a complex beast. So why is it that we, even though we're seeing some really cool stuff in mining, why do we still seem to feature on such a low scale there?
Yeah, so I think, mining traditionally, mining has been very resistant to change. There's a couple of reasons for that. It is a 24/7 production environment, and yeah, normally, it's the guys on the floor don't really coming from that place. You don't want to risk your current operation. You want to use the tried and tested, sort of hanging on to old legacy systems, and You know, so I think often you just don't have time to implement these systems, and you know, a lot of times, you know, there's a certain, well, from mining side, we feel that there's a certain risk involved. So yeah, that's sort of, yeah.
Again, just with this evolution of technology, I just wanted to show this slide again. I think by now everybody must have seen this type of industry 1, 2, 3, and 4.0. So it only sort of came under my attention less than 2 years ago, but since then it's really spread like wildfire. So I'm not going to really go into any detail here because I'm really sure that you guys have most of you have seen this before. I think it's interesting to just think in terms of where are we at in terms of mining? Are we actually in this industry 4.0 space, or are we still in 3.0 space? And I think you could probably quote instances where we can say we are already in 4.0, but then that's maybe not fully integrated across the whole value chain in mining. The next slide, again, I want to think a bit about how is you know, how is the technology developed over time. So in terms of the internet, the first thing that this internet has actually done for us is just in terms of connectivity, where we've got things like email, web browsers, and such. I don't know how many of you in the audience can remember the days before email. It was actually quite a revolution to all of a sudden being able to have email on your computer, and then you had email on your phone. And then a few years ago, we started looking at e-commerce and digital chain supply and collaboration. And then came social media. And now we're starting to look at fully integrating with things and with machines, fully autonomous vehicles, etc. So things are really moving at a fast pace. And I think, again, in terms of mining, if you just think, where are you on this scale? Are you in terms of what you're doing? So Brian, this is something you came up with. You said this was the first example. Well, what happened here?
Yeah, so this is actually the first example of a Internet of Things. Let's call it what it is. It's networking with a machine. And it was done on a Carnegie Mellon University. So a couple of local programmers, they got tired of getting to the machine only to find that there's no Coca-Cola left. And also, you know, sometimes getting to the machine only to find out that the Coca-Cola that's in there is still hot. So they basically connected to this Coca-Cola machine and then wrote a small little program to tell them, you know, is there Coke available, number one, and number two, is the Coke cold? So yeah, this is the start of everything back in 1980.
Yeah, which is interesting because I think the birth of the internet itself was only in 1995. So this was really Internet of Things maybe on a local scale. But I think, you know, by that time mines were already doing quite a lot of automation and that on a local scale with PLCs and so on. But I think things have moved on quite a bit. So exactly what is IoT? So we found an interesting quote there. But I suppose in your own words, what would you say is, what is it? What is IoT exactly? What does it mean?
Yeah, so I think, you know, IoT, it's basically taking low-level information from sensors and turning it into very high-level knowledge, you know, that can be used to incorporate smart objects, humans and machines. So it's, yeah, in essence, that's what it boils down to.
Okay, so I just wanted to talk a little bit about where things are going, certainly with the developments that we've been doing recently, and I think there's quite a lot of that out there. There's still in the industry old style historians are calling it old style because you know, it's actually a fundamentally different type of historians that's still installed on many mine sites, and then IoT systems are typically built on top of that. We actually, some of the new developments we're looking at is different types of historians, like time series historians, and now we can actually fully integrate cloud and on-site historians. So some of the features of this is that old style historians typically limited by tags, and it's also priced on tags. So whereas a new style of cloud IoT type historians, the tags are really unlimited, and it's really just priced on the amount of data or the amount of storage that you need. Also, what I often find with old types historian is that every department seems to have their own historian, you know, and now we're trying to get it all the data in a central place. There also seem to be quite a limited usage of data with older style historians, where maybe you've got the metallurgy department and they'll be using the data, but operators maybe don't have access to it, or maybe the maintenance department have limited access to it. Certainly offsite managers have limited access to it. Suppliers don't have access to it. So consultants maybe have access, but only once it's sent to them in an Excel format. They don't have direct access to the data. So this really starts to give you a flavor of what you can actually do with IoT type technology now, where you can have much wider access and people can see the relevant data with an IoT system. There's also limited redundancy, whereas now you can have fully synchronized systems in multiple locations. The overall cost of ownership of the traditional historian systems can be quite high, especially if you now build an IoT on top of it, whereas if you have a fully integrated system, it's actually quite a low cost way of doing it. Yeah, so I mean we can keep on talking about it, but I think this is one of the areas. The topic of this was how is it going to revolutionize the industry, and I think this is one of the potential areas. It's just the whole storage of data could be done quite differently in future. So what exactly is big data, and are we dealing with big data in mining? I mean, I have had polar opposite views on this, Brian, and we actually found a definition. Again, Gartner is a great source online. They publish all sorts of things. So we found this interesting definition there. Big data is high volume, high velocity, and high variety of data. So how does that, do you think we are dealing with big data in mining, or
yeah. So it's an interesting question. You know, if you look at Gartner's definition there, high volume, high velocity, and high variety, you know, most people coming from the mining industry, you'll know that a lot of the data, especially data used in the counting systems and things like that, is basically, you know, shiftly, daily. So it's point data. You know, it's not, it's generally not big data sets. And also, you know, if you start going into the SCADA with all your sensors and things like that, it can get high. You know, it's the amount of data or the volumes. But if you look at the instantaneous point generation amount of data, it's not really that high. You know, in terms of velocity is definitely there in terms of certain sensing capabilities. And then in the variety, you know, that's where it gets interesting, because I think mining is a prime example of you have data coming from all sorts of different sources. You know, you've got sensors, you've got weightometers, you've got manual inputs coming from assay data and things like that. So, you know, in a certain sense, you'd say that, you know, mining is not big data. But then if you look at the analysis of the data, typically, you know, what you would expect is that for you to start doing forecasting on models or to do analysis of what happened in the past, you know, then you start expanding it into time series. And as soon as you start doing that, then that relatively low amount of volume gets very high volume very quickly. So in that sense, it actually does turn into big data.
Okay, so just to look at a typical IoT infrastructure there, typically you take data from the plant, so you're going to have multiple traditional sensors and new sensors, but also now an area that we're looking at is to actually collect data from human activity. You know, what humans typically will do. Yeah, then you actually digest that into your cloud server, and also you can then start using that data. So you're looking at the input layer, the network layer, and the application layer. So I think we want to speed up a little bit on this. So we're going to skim through again on the input layer and the network layer, so we can get to the application layer, which is really what is interesting for us. So the input layer, just very briefly, Brian, can you just tell us a little bit, just briefly on that, what we're looking at?
Yeah, thanks, Peter. So very simple, you know, it's the physical layer. It's your physical objects, sensors, actuators. You know, it's there's a number of considerations that you can look at, but yeah, in basic sense, it's just your physical layer, your input layer.
So I think what we're fortunate actually with the implementations that we've done is that a lot of this information is already digested into a local site historian. So quite often your site historian becomes your input layer, but you can then start putting additional instrumentation in there as well, and also collecting other manual log sheets and manual data as well. The network layer, again, just briefly, how is this different from traditional networks? How is an IoT network different?
Yeah, so again, just very quickly, so network layer, you know, obviously you need to consider different technologies and how they integrate with your input layer. But you know, the network layer is quite critical in terms of the IoT sense, because this is typically where you're building your abstraction layer, you know, and this is what you require for that seamless integration of your heterogeneous data with the application layer, you know. So this is basically where you remove all that variety and things like that. And then also, you know, security and privacy is something that you also typically start building in this layer.
And then getting to some of the good stuff, the application layer. So we've got a few screen grabs from our IoT system where we started looking at building a digital twin of the mine and also some data analytics. But in a general sense, what would you understand under the application layer?
Yeah, so just again, just briefly, you know, application layer. So that's basically the interface between the network and the actual applications that are working on this IoT platform. And then if you look at the actual business layer, you know, this would be the very high level layer where you start leveraging this, you know, in terms of machines, human, people, processes. Yeah.
Okay, so the platform actually refers to all of this together. So the definition of a platform is really all the hardware and software that is needed to implement the solution or a system. So it includes all the data, the hardware, the applications, and then also the ultimate solution. Again, a platform implies that it can be applied over a very wide variety of areas, including the entire value chain of the mine. So I'm not going to go into detail on that part of it. And then what we're talking about on the next part is the actual ecosystem, which is interesting because we're busy putting together an ecosystem. And I've seen there's a lot of accountants and other consultants and so on that's also logged in today's webinar. And I suppose this is also an introduction to other people. We've also built a platform to be able to connect mines to accountants, to meds companies, to suppliers, etc. So something for you guys to pay attention to, as well as how this actually works. So this is building together an ecosystem using the platform as an enabler for people to actually provide their solutions to mining companies. Just as a recent example, we've used this platform to actually have a number of different companies. We've got, we actually applied for Meds Ignited funding with this, and this was a collaboration between Orway Mineral Consultants, Curtin University, Jameson Consulting, etc., and the Australian Institute of Machine Learning. And then also we supplied solutions to different mining companies, including Perseus, Evolution, and BHP. And what it really means is that the platform, or the IoT platform, is really the enabler to be, it's sort of the glue that holds it all together. And different IoT applications that we could be looking at is process modeling, digital twin, more automated meta accounting, more automated environmental reporting, safety, etc. And then also being able to interact more with external suppliers and for example, sending relevant data to them. If I just use a simple example there where we've implemented an IoT system at a plant, they've got many internal uses, but one of the external uses is that the level of the lime and cement is actually sent to their supplier, who then automatically gets an alert. He fills up the bin levels and he gets paid automatically, all enabled through the IoT system. The consultant part is an interesting one. That's actually the whole Millrock thing that we developed with Orway IQ, Milling Remote Optimization Consulting, and that will also enable us to connect with other consultants as well. So I'm going to talk a bit more about that part as well. So in terms of meta accounting, again, I'm going to ask Brian to comment on this, but I've recently visited a mine and I sort of, again, just refocused on what's involved in meta counting, everywhere from the sample collection to actually getting the data back out and actually writing and giving your final meta counting report. How do you, I mean, at the moment, how do you see that? What's actually happening there? Is it how automated is it?
So yeah, I think anyone who's done meta accounting before knows the frustration of having to open 5 million different Excel sheets at the end of the month and trying to reconcile data, and then only to have to start it all over again because you received the Excel sheet from the other meta accountant on the other side. You know, so it's painfully frustrating. It's a process that's you know, it's so ready to be disrupted by automation. And yeah, as you rightfully said, you know, you can extend the automation all the way to the phase and to the actual physical layer where you actually collect the samples. I think, you know, we typically we tend to forget that that's actually where the information starts, and not from the assay lab and from an Excel sheet. So yeah, a lot of scope there.
Again, you know, on another mine, I've actually had some interaction with the environmental department to look at what do they spend their time on, and realize that a lot of their time is actually spent on using FTP to connect to remote computers, remote environmental monitoring stations, weather stations, and downloading data, actually taking drives out to tailings dams, collecting samples, taking it to the lab, drawing up manual sheets, and eventually getting the results back in a CSV format from the lab, which is then imported into the environmental reporting system, and then that is output to the to a report again. Again, this happens on a completely different database to the one where the METs are working, or some of it is the samples might be on the MET system. You know, so the data is just everywhere. So basically, with an IoT system, all of this can be completely automated. Again, on maintenance, I think this is definitely the biggest expenditure area on mines. You know, it's basically mines or mining companies are really maintenance companies. They have to maintain their equipment to keep operating. Well, how do you think that can be improved with IoT?
Yeah, so everyone would know the feeling. You know, it's 2 o'clock on a Sunday morning, and you've just lost the motor. I need to find out that you don't have any spares on site, and you have to stop your entire plant for something as silly as a flotation cell motor or something like that. So, you know, maintenance in that sense, it can be a very expensive process. You know, it can come down to the smallest item. So challenges we had in the mining side is, you know, we basically we know very little. I think there's very little mines that do predictive maintenance. It's something that's coming in very big now. And, you know, apart from knowing when something's about to fail, it's important to know if you have stock for that item. So,
all right. Again, this is an area that I want to talk a little bit about, or just make you aware, is what we can do with this data automation. And this is actually what we've done with Always. We've looked at how do they actually normally do a report, and you know, we can follow a similar concept with any other consultant, and that's actually what we want to do. Is we want to connect the best domain experts in the world on this platform, on a platform, and you know, there's other people doing similar things to us as well, but this is really what IoT is enabling there. So what we do is, traditionally a consultant will go to a plant, he'll collect data, you'll do some simulations, modeling and calculations, you'll summarize the result in a report, and then a few weeks later the client will get the report. What we're now looking to do is we actually automate that process, and the report's results come out automatically based on live data. The data is automatically filtered, and it can be done for any period of time, whether it be for an hour or for a week or for a month or a year, and reports, that outputs of the reports is instantly available to the client and to the consultant. And the consultant's role is then not the role of filtering data and writing reports. The consultant actually become a coach and helping the clients to implement the results, rather than sitting there writing reports and sending out reports a few weeks behind the times. So yeah, that's, I think, really revolutionary application of this technology, and it's really served us very well, which we'll show in the next example as well. Again, we've worked with Jameson Consulting. This is another area, and I want to use the example here of a plant where we actually were working in the milling circuit, and we wanted to make some changes to the circuit. There was, for example, one set point where the cyclone feed pressure maximum limit was set to 65 kPa. And we needed to change that, because that was actually the constraint at that point in time. We needed to increase that to 75. Actually, it took about a month to figure out who's the responsible person for this and who actually can make the decision to change it from 65 to 75. So what we then realized is this is one of the things we can actually implement on the IoT, is actually have the person or the position that's responsible for making these changes. They can actually be notified that right now the set point they're responsible is actually for is constraining the plant, and we can make much faster decisions and optimize circuits a lot faster. That's just one example of a management operating system application, but there's many, many, many others that we're also working on. So case study problem. So in this case, we had a client where we've had a plant that was quite unstable. I'm not going to go through in a lot of detail here, but you guys can read it there on the screen. But suffice to say, the plant actually wanted to optimize the circuit, right? And so how did we actually go about this? This is what I want to focus on. So again, this is how we use the IoT system to enable this entire project. The IoT by itself, a platform itself, is not going to do it for you. It's really how you interact with it. So we've looked at this and we decided what we're going to call it is the value invention process. So what it all starts with is data, looking at measurements and all other plant data that's available, and really validating this. Now, each one of these steps can actually take a while. With some of our clients, we haven't actually got off first base because we're still dealing with the data and making sure the data is validated and we can use the data. But the next step, once you've done that, you move to the next step is information, turning that data into information by looking at things like analytics, modeling, and start having some conclusions from your data. And then from there, you actually want to use this data and control and optimization. So we use various techniques like model predictive control and real-time optimization. You can also apply AI and machine learning to that step. And then from there, this is where we work with consultants like OMC, but we've also got various others. And we're also working, for example, with Martin Verster. And we actually want to invite other consultants to work with us on this platform and start looking at applications at different clients. And this is where you actually use that knowledge and wisdom to review the constraints on the plant, and then you start implementing the change management plan or the management operating system, and then you go back and you evaluate the results. Now, again, we could probably have another arrow in there to start all over with this process if we can, because it is really an iterative process. So in terms of milling, I'll just give an example of how we've implemented something like this, or this concept in milling, where you actually get something like the mill slicer, which gives you a lot more information on your plant, on the mill specifically. And then we developed this milling remote optimization consulting, which really can be applied to any section of the plant again, where we're turning some of this data into more information. We then use model predictive control to optimize the plant, but control systems are really good at controlling the plant within a given set of constraints and then finding the best set of constraints to operate within. But you can't remove the constraints. The control system doesn't have the authority to remove constraints. That's where you need consultants and plant personnel, and really working on a coaching and working very closely with the plant to look at different constraints on the plant and how to remove those constraints. So that involves, for example, weekly interactions with the client, and then there's an implementation plan. How is this going to be implemented? Going back and then doing your return on investment of a project at the end of the day. Because if you don't do that, it never happened. So that's a very important step of the whole process. Again, that's a joint effort between the client and consultants, suppliers, everybody that's really involved in a project like this. So just give an idea of something like a product like mill slicer. You've got vibration sensors on the mill. So this gives you this additional information. I'm not going to go into this in a lot of detail, but suffice to say, it gives a lot more information that was typically available on a mill. So that's the supplementing the data and still using all the other data that's anyway available on the plant. Getting things like a polar plot gives you a lot more detailed information about what's actually happening inside of that mill. And then doing the process control. Daniel always says process control is making squiggly lines straight. I can think you guys can see that that's happened there. We've made all this squiggly lines straight. So, and then doing some more detailed analysis on the plant. So the data analytical component, again, is the screen grab of some of the things we've done there. And I think what's important here is to notice this area there where every day different areas is highlighted. So different bottlenecks on the plant. If you look at the bottom left corner there, control limits. Where are the control limits? So the Millstar will actually output this information so that we can then review this with the consultants and say, well, why is the feed water set point at 0? You know, maybe there's too much water in the circuit. Why is the sump level not right? So this is just a few simple examples, but every day that's basically different. Again, you then build the digital twin, or you basically, in this case, we've got a mass balance of the plant. And if there's a problem with it, it will show up red. So you can clearly see there's a problem in a particular area of the plant. Again, you can do more detailed analysis on this result. So this is just some of the results. So you can see the reclaimed feed right there in the sag power. All the blue lines was before we did the implementation, and all the orange ones was after. So you can clearly see that the power and the reclaimed feed rate has increased. The next slide, we've got a summary of total new feed tons in that case, increasing the mill feed rate in tons per hour. So that's actually, so the total new feeds actually increased by 18%, and the fresh feed rate has increased by 8%. The reason for the difference is that it comes from the fact that there was less strippages, longer liner life, etc. This oxide ore was actually, the oxide is actually easier to process. In fact, that shows, despite the fact that the oxide was less, 17%, there was 70% less soft ore. So there's actually more harder ore. The tonnage still increased, and mill availability also increased. So what this really shows is it's not a silver bullet. This is a result of a project that's probably to date lasted probably about 4 months or so. And it's a result of a very close collaboration and different disciplines working very closely together to achieve this result. There was no new hardware installed, no new crushers or anything like that. It's still the same circuit. And you know, basically that just shows you what can be done with data. This was all done with data. They're just analyzing the data, giving feedback, optimizing the control, etc. So just in terms of a few comments about the future, Brian, back to you. I think you wanted to make a few comments about increased IoT and where things are going.
Yeah, so the graphs you see here, I just want to highlight one thing. You know, if you look at the in IoT sense, you'll know that any network that you implement, you know, it all starts out, everyone starts out with good intentions, and before you know it, you've got people adding more and more sensors onto your network, and people want more and more from the data. And you know, what typically tends to happen is as you increase the number of nodes in your network, your energy consumption increases. And then also with the increase of nodes, you increase the amount of latency in your network. So that's basically the delay in transferring data due to various items. So yeah, that's just what I want to highlight with that slide. And then if you look at so basically where everything's going to currently with the Internet of Things is to try and remove some of the data processing out of the actual cloud computing and the data processing. So what we basically refer to it as edge computing. And I've got two pictures there. The first picture there at the top you'll see is the legs of a spider mite that's standing on gears from a micro engine. So these micro engines, it's called MEMS. It's micro electrical mechanical engines, and they basically it's the mechanical and the electrical parts that have been integrated as one part. So typically you also add then a little microprocessor to this. And so basically all the functions that you would traditionally carry out in your IoT network, in your networking and middle layer, would now be moved to the actual source of the data, as close as possible to the source of the data. So that's just where things are heading currently. So if you look at that, we started off with traditional computing, which then went into cloud computing, as I just spoke about now, edge computing, and then this will probably go into what we call or refer to as ubiquitous computing. And ultimately, I mean, who knows where we'll end up, what the future lies has in store for us.
Right, that's the end. I think we're 40 minutes, 5 minutes early.
Perfect. Thank you, Peter and Brian, for the presentation. That was fantastic. We do have a question here already for you both. How do you collaborate with other consultants and METS companies?
So we've got quite a flexible model still at this point in time, but basically we make the platform available for the other consultant or METS company to build their solution. Sometimes the solution can be as simple as actually visualizing the data, but it could also be a more complex solution. So we then help with the development and implementation of that. The consultant or METS company actually is the interface with the client, so they will sell their solution to the end client. And ideally, I think the benefit is that if multiple METS companies actually start dealing with the same suppliers, then we all start working off the same platform. So I'd say basically in summary at the moment, it's the actual business model of it is quite flexible, but we really start from the premise that in the first instance, we look at what is the value proposition for the end client, and then we work together from there. And we can work as closely or as arm's length as people actually prefer to work with us.
Perfect. Another question is SAP versus IoT. Can you compare and place in context?
SAP. Okay, Brian, you go.
Okay, so SAP is basically it's an ERP system. So if you look at SAP as a ERP, it's a enterprise resource planning tool. So basically, you would integrate data from a large range of sources. SAP's got functionality to do predictive maintenance, well, to get the data for predictive maintenance and things like that, as well as production information. So, in a sense, you would say that SAP does form, type of IoT calculations. In my personal experience with SAP, it's quite a top-heavy system, and it's not made for to integrate for applications. It's not very application friendly, and this is typically what we see with ERP systems. They've all got their own standard of data, their own standard format. So if you had to try and build the actual application layer on top of SAP, well, you basically have to build your own application layer on top of SAP and then access the data in that way, because SAP, I don't think it would have the actual computing, that the format of the data is in such a way that you would struggle to do actual machine learning and artificial intelligence type of calculations in SAP itself. So I'd say SAP or ERP systems, it would integrate with an IoT platform typically, and you would export some data out of SAP, which you would then use. And in your IoT platform, you would basically convert that in your application layer into data that would be more suitable for carrying out machine learning and the type of dashboarding and things like that.
Good.
Fantastic, thank you. Someone just made a comment about the case study saying the results look impressive. Can you say who and where?
No, not at this stage. We're busy preparing abstracts and so on for publication. So at this point, we can't unfortunately mention the client's name.
Not a problem. Another question for you is, what can a mine do to start using IoT?
Okay, that's fairly simple. I think we have actually different types of clients. One client would maybe come to us with a very specific problem where we more focus on the solution. In other words, let's say they want to increase their throughput, so we go through that whole process that I've explained before. But we do have other clients that's just looking at it as a replacement or as an actual historian, and then gradually start implementing their own solutions on their own plant as well. So, and then it's really just I suppose, a coaching role that we have. So we make the infrastructure and the platform available, and we work through with the client. So it's really, there's many different layers and levels that you can start with. I would say for most mines, a very logical way would be to start looking at it as an historian, or if you have a really reliable historian, you can actually build on top of your historian as well.
Great, thank you. Another question is, often the data is siloed between each department. To my knowledge, there has been no IT provider that can encompass the data collection from all disciplines. Any thoughts on how to put together integrated data from mining, geology, metallurgy through to finance?
Okay, Brian.
Yeah, I just want to add on that. I definitely shared Dean's frustration. Well, I did share that frustration. Typically, people operate in silos. Geology don't know what metallurgy is doing. Engineering don't know what process is doing. So yeah, I can definitely see there's a big need there, Peter. But I'm sure you can explain, how the value invention platform can suit that.
Yeah, that's actually the maybe it's one of the concepts I wanted to bring across with this as a webinar. But I think we'll need to work a bit on explaining that. But the IoT is really powerful with that actually. And what's interesting is, for example, I just give a couple of examples. With the IoT platform, we're connecting directly to an on-site historian, or we're installing an historian on-site. Now that will communicate with all the PLCs and so on. So we have a link to that, and then we also have another link to the, let's say, output device on a specific instrument, and then all that data is collated in the same time series database. So you can actually connect to any historian on site. Even if there's 10 different historians, you can connect to all those different historians and collect all that data into the same time series database. So the technology is there. The technology is not the problem. It's the people that's the problem. And it's the systems of actually convincing everybody that this is what we need. We need all this data in the same place. And then once you have it in the same place, start looking at the applications and how are you going to use it in the same way. But it can be quite a big job. I mean, you can start small, but ultimately what you want is a really high level approach to say, okay, look, this is what we're going to do. We're going to look at all the data from everywhere and collate it all in the same place. Does that answer the question? So, but yeah, that's basically my view on it.
That sounds good. Thank you for that. Another question for you is, the biggest problem I have encountered accessing big data from sites is the work needed to arrive at a usable data set. There is a lot of rubbish coming out of sites, interpolated values, bad and possible outputs, and there are many means of dealing with zero data values, for example. Is the cleaning and verification of data automatable in your experience?
Yes, I think this is one of the beauties of the beautiful things about this platform as well. The one we've been working on now. I just want to stress that there must be more than what we do out there as well. We're not the only ones doing this, but in our case, we actually filter the data automatically. So this is really nice because you can actually sit in front of your computer. the data is already filtered, you can say, listen, I want to look at the last 2 hours worth of data, or I want to look at the last 2 days worth of data, or I want to look at the last 1 year's worth of data. So actually put in rules and executables to filter the data so that it becomes usable in a usable format. And I think this is that's really powerful part of it. Probably we've actually had comments from various clients that they'll be interested in just for that purpose, just for the data filtering is what is really powerful.
Yeah, I just want to add on that, Peter, so if you look at where the data comes from, it's always the easiest to try and sort it out at the source first, before it gets into your system. So what we basically do well at ProSite is we have the ability to build really good dashboards, to really focus on the end user experience. And I find that if you can limit, what the operator could, let's say it's a manual value that he can be logging in there, to try and limit what can be logged in there already. So to try and filter on the actual physical layer itself, with the input layer already, I think that also tends to help in addition.
Yeah, so one of the things that we've, for example, found with the system is that it helped us to, once we built, for example, a mass balance online, it very quickly points out where there's problems with the data. If there's one density probe that's out, that'll come out of the mass balance very quickly. So we've had a few clients that actually got stuck at the first base and said, hey, listen, your density probes are not working. So first go back and fix all this instrumentation, and then we'll move on to the next step. So that's just one example where by actually analyzing the data, you can actually get a very quick idea of which data doesn't work. It's incorrect, basically.
Fantastic, thank you both. Another question for you is, every company has their own data security policy, and it often becomes the issue with technology providers to obtain data from the sites. Any comments on this?
Yeah, I mean, it seems to be a thing that everybody is saying is that there's a big problem with that, but we've got several clients now, including some of the biggest mining companies in the world, that we have access to data. And I think once you've actually talked through in a logical way with if the people wanting the solution, let's say the mates and the plant managers, if they want the result that you're offering or the solution you're offering, they will give permission. Then you have to convince the IT department that it's okay. We're not going to, basically sink the plant. We're not going to put the plant at any sort of risk. So you have to go through the technical details. Some clients actually taken weeks to get through that process and different layers of approval. So whereas I think a few years ago, if you said 5 years ago, maybe it would have been completely incomprehensible. But as people's understanding now increases and their awareness of what can be done to do things in a safe way, gradually these problems are actually being overcome.
Great, thank you. Another question is, how does the remote access work?
Okay, so there's more than one way. One way is you can actually connect directly to a plant historian with only outgoing access, so actually data is only sent outward from the client. Another way is you can connect through the cell phone network to actual individual pieces of equipment and instrumentation directly through the cell phone network on plants. So yeah, that's two ways, two different ways it can work. But there'll be others as well.
Perfect, thank you. Another question is the connecting / collection of the data done in a secure way?
Yeah, I think that's a very good question. Yeah, basically, that's one of the first things that we always get asked, I suppose, on clients. And once you explain to people that the collection of data is done, for example, through an outgoing port, and that there's the client also have their own types of firewalls installed. For example, data is exported to a local site historian, and then we read from the local or actually the local site historian pushes the data out. So this is not exposing the plant in any sort of way, so that the access to the plant is very secure. Then once the data is out and it's actually stored on a cloud historian, which by the way is optional, it can be stored only locally as well. But once it's stored out outside, it's also encrypted and encoded as well. So which means the data is actually very secure. And it wouldn't be easy for somebody to hack into the data. Yeah, so that's basically in terms of the security, how that's handled.
Fantastic. Well, if there's no more questions, I'd like to bring this webinar to a close. Thank you, Brian and Peter. It was a great webinar, and on behalf of the AusIMM, we really appreciate your time and effort. And thank you to everyone who's watched this webinar today, and we hope you watch more webinars in future. Have a lovely afternoon, everyone.
Thank you, Alice.
Thanks.